Hello there, thank you for joining us today. I'm here to take you through another set of differential definitions, and this definition we are going to look at is what we are going to call derivatives of exponential functions. So derivatives of exponential functions. So what is an exponential function? An exponential function is one which will be in the form y, for example, is equal to e of x. If e is a number, definitely, e is a number. So if that number is raised to a function x, at coordinate x, if you look at the coordinates, if you have a point which is 0, 1, then the derivative or the gradient function of that function or of that curve at that point is going to be e of x. Meaning, if you differentiate the derivative of e of x, you always get e of x. That means that if I differentiate an exponential function with respect to that function it is raised in terms of, I'll get that very function. That would mean if I have the derivative with respect to y of e of y, still the answer will be e of what? E of y. Whereas if I have maybe a derivative with respect to p of exponential e of p, then still I'll get e of what? E of p. Now, sometimes we can borrow from chain rule and we see how this comes about in the various examples. And for example, if you have a case like this one, you can have example 1. Find dy dx given y is equal to exponential of 3x squared, for example. In this case, we shall let y be equal to e of 3x squared, and you let your u, for example, be 3x squared. If u is 3x squared, then get the derivative of u with respect to x, which is 6x. That means y will become e of u. Now, y becoming e of u, it is in this state. So we can differentiate y with respect to u. Because of this relationship, it means it's the derivative with respect to u of e of u. And it is from here that this still remains e of what? E of u. Because of it being an exponential function. Then we borrow from chain rule. Dy dx can be got from dy of du times du of dx. I have dy du as e of u. I have du dx as 6x. Therefore, my solution will become 6x exponential of u as the derivative of y with respect to x. Now, the question never had u. Bring back the x which was given. So the derivative of y with respect to x now becomes 6x exponential of 3x squared as the solution. Remember, there are some types of integration we discussed, and at one point they will bring functions which have a term, as you see this x comes from the derivative of that one, and then you can use the technique of inspection method and then you go backwards. We shall see that also. But right now we need to first know how to differentiate these exponential functions. So that was example 1. Example 2. Given y is equal to exponential cos of x, we can let u be cos of x, then y will be e of u. Still dy du now is the same as exponential u, whereas du of dx is going to be a negative sign of x. From that regard, you will have dy of dx is equal to dy of du times du of dx from the technique of what we call chain rule. It's among also the examples or among the videos we have that we talked about that have what we call chain rule. So you can go back to those videos and see some of those techniques. dy du is e of u. du dx is a negative sine of x. So my solution will become a negative sine of x exponential cosine of x is the derivative with respect to x of e of cos of x. Now, note, the time is going to come when we shall have an integral of sine of x exponential cosine of x dx. This is what the exponential is all about. This is what the derivative is stating. So you ask yourself by inspection, where does this come from? I'm just talking about it because time is going to come when we are going to integrate exponential functions. But in that sense, I want you to first know that if I have this derivative and takes me to that, then I can come back from here going back this way using integration. So to get what I differentiated to arrive at this one, I make the negative come on the left hand side, then the answer will become a negative exponential cosine of x plus a constant. So this knowledge will be needed later on. But for now, we are still handling derivatives of derivatives of exponential functions. So this is going to take us to example 3. Example 3, we can have derivative of x exponential sine of x. They're asking you to differentiate those two. This time around, these two are combined, so they are a product. If they're a product, we shall need to borrow what we call product rule. So from product rule, because product rule, you're differentiating this with respect to x. So this I say differentiate. From product rule, we shall have to differentiate with respect to x, a half x, keeping sine of x a constant, plus keep x over 2 a constant, differentiate with respect to, this is exponential, differentiate with respect to x exponential sine of x, because in product rule you differentiate one term keeping the other what? Constant. It is from here that we shall get, when I differentiate a half x, I'll get a half, which is a half exponential sine of x, plus I keep x over 2 a constant, differentiate sine. We have already seen from the change of variable, it means that the idea is that differentiate the term power to the exponential. So when you differentiate cos of x, you get a negative sign. So the solution for this, without going through the chain rule, because now if this requires you to have secondary relating, you'd rather now get the solution straight away and say the derivative of cos is negative sign, exponential of the original function. So here I can say x over 2 times derivative of sine is cos of x times the exponential of sine of x. Therefore, the solution will become a half exponential sine of x into brackets 1 plus x cos of x as your solution. This is coming in if you have a product of two functions that require differentiation and one of them is in terms of an exponential function. Okay, then number 4, example 4. differentiate exponential tan of x. This is going to be the derivative with respect to x of exponential tan of x. And you have said you first differentiate the tan and you get what? Sec squared of x. Exponential of the original function. And that will be your answer. Come to example 5. Now this is when we start using them and doing them directly without going through how exactly they came about. What if I'm to differentiate with respect to x, exponential cosec of x. The derivative of cosec of x is a negative cot of x times the exponential of the original function. Sorry, this is a negative, the derivative of exponential of x. Okay, let me write it up here. The derivative of exponential cosec of x, the solution is a negative cot of x. You first differentiate the power, cosec of x times exponential of cosec of x, and that's our solution. So if you are to differentiate such a term, then the result is going to take a look like that one. So in your free time, investigate for me the following. Differentiate the following. Exponential 3y, exponential of negative sine squared of x, and then 3 exponential of bx plus a. So in general, the general definition is the derivative with respect to x of exponential of that function. The result is always the derivative or the first derivative of the power, exponential of the original function, and that is what we can use always as the definition if we would like to have what we call derivatives of exponential functions. I have been your teacher today still. My name is Hamza, and I have been here taking you through what we have called derivatives of exponential functions. Thank you for joining in and liking our videos and watching them. Please keep doing so. Those of us who are interested in online classes, we are supposed to begin on Monday, especially those in Uganda. Any other countries which speak English, those who are also interested, you can always contact us and we see how we can assist and come to your rescue in terms of mathematics and perhaps physics. Thank you for loving our channel. Thank you for liking it. Keep liking, keep subscribing. In case of any concerns, please revisit the channel and watch it again. Share it with your classmates, share it with your teachers. And in case of anything, please, you can put it in the comment section. In case of any different topics you want us to look at, please go in the comment section and always make us get to know which areas we can put more emphasis on for you to enjoy our channel. Thank you so much.